A very good evening to all of you. Doing great? Okay. So we are in the last concept that we have to be discussing. That's normalization. So let me first tell you what is this normalization is all about and why is it necessary for us to understand. Because you all understood why is that we are discussing on the ER diagrams. You understood. It acts as a blueprint for the designing of the databases that you want to be having for your softwares or for your applications. Similarly, what is this normalization? Let me tell that part to you, dear students. So normalization is nothing but we tell it as a process. Okay, it's a process in which what you will be doing is you will be decomposing the tables. And what do you mean by this decomposing? It is some technical terminology. So decomposing the tables are nothing but you will be splitting the tables. What you will be doing? You will be splitting the tables. That is what you mean by the word decomposing technically. Okay. Why is it? Why you have to decompose all of that you will be understanding. So why it is because say suppose you have certain problems, you have to overcome those problems. That is where you will be performing normalization. Say you all already know why do we need joins? Because the data will be present in multiple tables. Say suppose I want to fetch data from multiple tables. That is when we perform joins and we fetch the data. Similarly, what is this normalization? Normalization is a manual process again. What you will do is you will be having data with you. Already the huge set of data will be available. And what you will be doing is you will be splitting the tables. Ma'am, why we have to split the tables? Randomly will we split? No, randomly we will not split. In a systematic way, we are going to split the table. That is what is meant by normalization process. Why? Why? Because in order to overcome the problems. Why? Because in order to overcome the problems. So what are the problems? Let me first tell you what are the problems. So if I tell problems, there are three problems that we are going to discuss. One is something called spurious tuples. Another thing is something called anomalies. And third problem happens to be data redundancy. All these are the problems. In order to overcome these three problems, we are going to perform the normalization process. Okay. Dear students, anywhere have you heard this word? Spurious tuples? No? You've heard tuples at least? What do you mean by tuples? Rows. Correct? Rows. Yes. So it is a problem related to the rows. What is it? I'll be telling you. Similarly, we have something called anomalies. What are anomalies is, if at all, say suppose you are performing any of the DML operation, maybe you're performing insertion operation, maybe you're performing some deletion operation, or maybe you're performing some updation operation. So say suppose whenever you're performing these operations, if you find any problem, technically problem is called as anomalies. So we have three anomalies: insertion anomaly, updation anomaly, and deletion anomaly. So three anomalies we have. Got it? The problems that you get probably while inserting or while deleting or while updating, that is what you call it as anomalies. And data redundancy, already you know. Data redundancy is nothing but repetition of the same data within the table, which leads to memory wastage. If in case same data is repeated, it leads to memory wastage, right? If it is present only once, it is enough. So repetition of the same data within the table, which leads to memory wastage, we call it as data redundancy. So in order to overcome all of these problems, we have to perform the process of normalization. Maybe now first let me tell you what is the spurious tuples. In order to tell that spurious tuples, I will first consider one table here. Maybe let's assume that I have one table Inside that I have 3 columns, column A, column B and column C. I have 3 columns. Maybe inside column A I have the values like this. Maybe inside the column B I have the values B1, B2 and B2. Maybe inside C1 column I have C1, C1, C2. All these happens to be the values. Assume that I have one table and inside that I have the records like this. The values are stored like this. Now what I will be doing is, due to I had some requirement, for that reason, I will now decompose this table. What I will do? I will decompose this table. I told you, what do you mean by decomposing? Splitting the table. Okay, so what I will do is, keeping column B as the common column, I will split the table. So how I am going to split is, here I'll have one table and in this table I'll have column A and column B. And to consider the values, I have A1, A2, A3, B1, B2, B2. So like this I have, and as I told, I'll keep B as a common column between both the tables. So in this table, I'll have B and C. So I'll have the values B1, B2, B2, C1, C1, C2. Like this, I will split the table. Due to some work, I have splitted the table. That is nothing but decomposing the table. Next, what is, maybe for whatever reason I have splitted the table, my work is done. So now what I will do is, I will again join these two tables. Are you all understanding? I had one table, I have splitted the table, I have decomposed it because of some work. So because of some work, I did that, keeping B as a common column. Now my work is completed. So what I will do is, I will again join this table. With join, I can go with inner join, equi-join, any of the join. Maybe I'll go with natural join. Why? Because natural join will keep the common column name only once. That is why I'll go with natural join. So when I say natural join, I'll be having column A, column B and column C. However, B column will come first, but I've considered it in the second column. So like this I'm going to get. You know that only matching records it will give. So A1, B1, B1, is it matching? Yes. So that record will be there. A1, B1, C1. So I will have A1, B1, C1. For B1, is there any other match? No. Correct? There is no match. So next row, A2, B2. So for B2, do we have match? This is B1, this is B2. Yes, there is a match. So it is A2, B2, B2, C1. So which means A2, B2, C1. Again, if you observe for B2, there is one more match. So it is A2, B2, B2, C2. So it is A2, B2, C2. Next, for this row, it is all the matches we have checked. The third row, A3, B2. For B2, again, B1, no match. B2, yes, match. So B3, B2, B2, C1. So it is A3, B2, C1. Again, for B2, there is one more match. So A3, B2, C2. So it is A3, B2, C2. Only these many matches. Do we have any other match? No. Now carefully observe all of you here and tell me, A1, B1, C1, is it present in the original table, actual table? That row is there? Okay. A2, B2, C1, is it there in the original table? I mean actual table? Okay. A2, B2, C2, this tuple, is it there in the table? In the actual table, it is not there. Okay, I'll just tell here. A3, B2, C1, is it there in the original table, this row or this tuple? No. A3, B2, C2, it is there. So whatever is here, dear students, all of you are getting it? If you observe, we have two records here which are not present in the original table, but they have generated when the table is decomposed and further joined. So such tuples are called as what? Such tuples are called as spurious tuples. Did everyone get this? So what are spurious tuples? Spurious tuples are such tuples which are not present in the original table but gets generated when the table is decomposed. I have told you decomposed is nothing but splitted. You have splitted the table and it is further joined. That is what you call as what? Spurious tuples. And these are the spurious tuples because they are not present in the table. They are unwanted rows which have been generated when we have performed decomposition and joined it. So this problem we have to overcome, and we can overcome that by the steps, by the process of normalization. Is this clear to everyone? Yes? So now what you do is, under the topic normalization, just leave 4 lines. Why that 4 lines? I'll be telling you. Okay? Below that, after leaving 4 lines, tell problems and copy all of these 3 problems, and tell spurious tuple and copy this. Why those 4 lines you have to leave? You will understand. Kindly copy it in the way which I have told. So take down. Below this, take down. Spurious tuples are such tuples. Spurious tuples are such tuples. Spurious tuples are such tuples. Spurious tuples are such tuples which are not present, in the actual table, which are not present in the actual table, but gets generated, Spurious tuples are such tuples which are not present in the actual table but gets generated when the table is decomposed. When the table is decomposed, and further joined. I'll repeat again. Spurious tuples are such tuples which are not present in the actual table but gets generated when the table is decomposed and further joined. You should be knowing what you mean by decomposed. Decomposed happens to be splitting the table. Technically, that is what it refers to. Keep that in mind. Next year, students, you understood about spurious tuples. How do we overcome this? By performing the normalization process, we can overcome the spurious tuples. This is one problem. And as I told, what do you mean by anomalies? Anomalies are nothing but, say suppose you are getting any problem. You are getting any problem. Maybe you while performing insert operation, or maybe while performing update operation, or while performing delete operation. If you are getting any problem, that is what you technically called as anomalies. So anomalies are nothing but problems that comes in the table. So there are three different types of anomalies. One is insertion anomaly, and we have updation anomaly, and we have deletion anomaly. Okay, ma'am, how can we get the problem? How you can get the problem is, say suppose you keep all the data in one table, and what is it is, maybe you want to insert a record. Maybe for one particular student or one employee, we have all the details, we will we'll just insert that record. Again, you will want to insert the next employee or next student record. There are so many values is missing. Only you're inserting only one value to just one column of that row. Like this, there are so many null values and you keep on inserting, which further leads to a lot of memory wastage. And there is no proper data that is maintained as well. So during insertion, if you have any of these problems, you call it as insert anomaly. Or say suppose you don't have the proper relation between the data that you are stored, and you're trying to update somebody's marks or somebody's age, and due to some improper data or not having it stored properly, instead of updating one employee's age, all the ages means all employees' age will be updated, or you will be updating all the marks, all students' marks. So any problem that you're getting while performing updation operation, or say suppose you try to delete one record, due to that you will lose some other data also. Are you understanding? Try to delete some particular data, but you lose other data also. So during deletion, if you are getting any problem, that is when you call it as deletion anomaly. So anomaly is nothing but problems that occur in the table while performing the DML actions like insertion, updation, or deletion. That is what you call it as anomalies. And there are three different anomalies: insert anomaly or insertion anomaly, you can tell, updation anomaly or update anomaly, and deletion anomaly or delete anomaly. Is this clear to everyone? So next problem, anomalies. Take down anomalies. Problems that occur in the table. Problems that occur in the table. Problems that occur in the table. Problems that occur in the table while performing yes, Shubhangi. It's like you get those errors because when you perform these operations, you have any of these problems. That is what is anomaly. Okay, technically anomaly. It is not just with respect to these insertion, updation, deletion. In the companies, if you have any of the problems that you are getting in the code, they try to check with this anomaly. Try to check with the anomaly is nothing but they'll ask you to check the problem. What is the problem? So remember, the word anomaly is nothing but problems. Technically, they call it that. Okay, what is that I told? The problems that occur in the table while performing insertion, updation, deletion. Insertion, updation and deletion. Okay. So there are three different types of anomalies. There are three different types of anomalies. Just write those three: insertion anomaly, updation anomaly, deletion anomaly. Is it done? Okay. So this is about the anomalies. Again, anomalies also, this problem can be overcome by performing normalization. Okay, this problem also we can overcome. And next is data redundancy. As I told, very simple, data redundancy is nothing but repetition of the same data which leads to memory wastage. You call it as data redundancy. Kindly take down for data redundancy. Data redundancy, repetition of the same data repetition of the same data repetition of the same data which leads to memory wastage, which leads to memory wastage, is called data redundancy. It's called data redundancy. Again, this problem also can be overcome by normalization. I hope everyone understood with respect to the problems, right? Everyone understood with respect to the problems? Okay. So these are about the problems that occur, and this can be overcome by performing normalization. I hope all of you got the clarity on the problems. So now we can take down where you left that 4 lines in the starting. Now I'll tell you what is normalization. Again, once we start that process, you will understand how we do it. But as of now, you can understand this much, that what is this normalization? The normalization is a systematic approach of decomposing the tables. Okay, it is a systematic approach of decomposing the tables in order to overcome the problems like spurious tuple, anomalies, and data redundancy. Now everyone understood? So what is normalization? It is a process, it's a systematic process of decomposing the tables. We will be decomposing, and we will not decompose however. Are you all getting it? We will not decompose however. In a systematic way, we will be decomposing it in order to overcome all of these problems. That is what is the process of normalization. Clear? So kindly take down this. Normalization is a process of systematic approach. Normalization is a process of systematic approach of decomposing the tables Normalization is a process of systematic approach of decomposing the tables in order to eliminate the problems like spurious tuples, comma, anomalies and data redundancy. The normalization is a process of systematic approach of decomposing the tables in order to eliminate the problems like spurious tuples, comma, anomalies and data redundancy. One more point, and nothing but, dear students, when we decompose, we are going to organize the data. Are you all understanding? See, in ER diagrams, what really happened was, we did not have the data. We just knew what and all should be there for that in order to store the data next. Next, we were storing the data. Before that, we were telling how the structure should be there. Structure of the table should be there. That is what we were doing in ER diagram. But in normalization, what we will do is, data will be already present. By performing normalization process, you are going to organize it properly. Are you understanding? You are going to organize it properly. So you can tell one more point. Normalization is a process of organizing the data. Normalization is a process of organizing the data. Got it? Okay. Okay, ma'am, now you start with normalization. Yes, dear students, even before I start with the normalization process, I have another thing to tell you. What is that? What is that is, heard this anytime? Determinant. Anytime heard? Okay. Another terminology is something called functional dependency. So even before I proceed with the process of normalization, you should be aware on, there is something called determinant and there is something called functional dependency. Okay, you have to be understanding this. What is this? I'll tell you what is it. Dear students, assume that I have one attribute X. Are you all getting it? I have one attribute, and let me tell, this attribute is X. And I have one more attribute Y. You know what are attributes? What are attributes? Columns, right? So I have one attribute X, I have another attribute Y. I will tell this X will determine Y. I will tell this X will determine Y. So since X is determining Y, I am going to tell that this X is the determinant and this Y is functionally dependent. Maybe I tell this Y is functionally dependent on X. Did everyone understand? Yes or no? How many of you understood? How many of you did not understand? Okay. Fine. Let me tell you. I have one attribute, student ID. I have one attribute, student ID. I have another attribute, student name. Okay. I have student ID as one attribute, student name as another attribute. Now I will tell the student ID will determine student name. Ma'am, what do you mean by that? What do I mean by that is, you only tell me, by knowing your codeness ID, don't you think I can determine what is your name? Yes or no? Are you all getting it? With the help of student ID, I can determine the value of student name. That is what you call it as determinant. So I will tell the student ID is determinant. Everyone understood now what is determinant? So what is determinant? If an attribute is able to determine the value of another attribute, that is what you call it as determinant. Student ID is able to determine the value of student name attribute. By knowing your codeness ID, I can determine what is your name. Are you all understanding? So that your codeness ID will become the determinant. Now, this name, don't you think it is dependent on the student ID? Yes or no? This is only called as functional dependence. If an attribute is dependent on another attribute, you call it as functional dependency. Why? Because there may be two students with the same name. But when I get to know their ID, I can identify who are they. Properly, I can identify, right? Properly, I can identify if there are two students with the same, with the help of ID. That is what it is. So what is determinant? If an attribute is able to determine the value of another attribute, you call it as determinant. And if an attribute is dependent on another attribute, you call it as functional dependency. This is what is determinant and functional dependency. Now everyone understood this? Yes? Okay, so kindly take down this. Online students, got it? All of you? Okay. Kindly copy this. Just tell it as determinant. Below that, tell functional dependency and copy both of this. Below that, I'll tell you what it is. Tell it as determinant, side heading as determinant. Okay. And below that, tell it as functional dependency. Copy both of the two terminologies. Below that, copy these two. And after that, I'll tell you what it is. So once I complete audible, once I complete normalization, after I finish this, I'll be solving few of the HackerRank questions. Okay. Kindly get your laptops. I hope all of you are carrying it for your programming classes as well. If in case you have not yet created any of the HackerRank account, kindly create one account and keep. Okay. So joins, all of those things, what we discussed was very minimal. I'll make you to solve on that platform where you will get complete idea on how you have to be using different joins concept. Okay. Not only that, many lot of other functionalities we have there, many lot of other functionalities, like we have learned things here, but with respect to just few set of data that we have there, we have it with respect to how the requirements come for the in your whatever the real implementations. So that is how it is. We will be solving that. Okay. Is it finished? Okay, take down. Take down. If an attribute is able to determine, the value of, another attribute. An attribute is able to determine the value of another attribute. It is called determinant. It is called determinant. Next. Next. An attribute dependent on another attribute. An attribute which is dependent on another attribute. An attribute which is dependent on another attribute. It is called functional dependency. It is called functional dependency. An attribute dependent on another attribute is called functional dependency. It's dependent, okay? And let me tell you, dear students, functional dependency will exist throughout the tables. Functional dependency will be there. But now next I'm going to tell you different types of dependency. Two different types of dependency I'll be telling you now. Those dependencies should not exist. Okay? Understand? Functional dependency will be existing throughout the table. But I'm going to tell you two different types of functional dependency now. Those things should not be existing in the table. Okay? What are those dependencies? I'll tell you that now. We have two different type of functional dependency which we have to be understanding. Which are those is, one is partial dependency. One is partial dependency and another one is something called transitive dependency. All of you are getting it? There are two dependencies, two different types of functional dependencies. One is partial dependency and another one is transitive dependency. These two dependencies, you have to understand what it is. If in case it is existing in the table, I told you in normalization, we have something called normal forms. Steps are there. In those steps, you have to be, these happens to be the conditions. In one of the normal form, we have a condition that there should be no partial dependency existing. And in another normal form, we have a condition telling that there should be no transitive dependency existing. Like this, those conditions are there. So that is why you should be knowing what is partial dependency and what is transitive dependency. Clear, everyone? This is what we should be knowing. So in order to tell you what is that, I am now going to consider one relation. Relation means what? Connection between the tables, that is relationship. I'm telling what is relation. I'm asking. Very good. It is table. Remember the terminologies in the first or second class, probably we have discussed. Right? Tables are called as relations. Columns are called as attributes or fields. Rows are called as records or tuples. Individually, what do we have? We call it as cell or domain. Right? I have told this. So coming to this, I'm now going to consider one relation, dear students. See, every time don't think that they will give the complete table for you and on that they will ask the questions. Sometimes, how do they represent is, they will represent the relations in Sometimes as a schema they will give. ER schema which we have seen, like that they will give, and they will ask you to write query. One common general query they will give, or joins query they will ask you to write. And another way they are going to give the queries or represent the tables will be, the relations will be like this. The name of the relation like this. Maybe I have a relation by the name student, and here within the parenthesis, what and all attributes will be there? They will be present. Student ID, student name, maybe let's say we have course ID, let us assume in the same relation, and I have course duration, then course name, maybe first I'll tell course name, then course duration, then maybe students marks, then students grade. Like this, I have few attributes. This is another way of telling you the relation. So this indicates the name of the relation, name of the table, and all these indicates the attributes. This is another way they will give you the attributes. I mean, they'll give you the relations. Like this, they will give 2-3 relations, and they will ask you to write a query on it. Maybe joins query and all of that. So then you have to see which is the common column that becomes the foreign key. All of those things you have to identify and you have to write it. So keep this in mind. Okay. Now coming to this, I have to tell you about partial dependency and the transitive dependency. Correct? I have to tell you this now. So what is this? What is this partial dependency, or what is this transitive dependency is? Dear students, kindly observe this relation. If you observe, this student name is dependent on student ID. Correct? Can I tell this as determinant? Yes or no? Yes. If you observe, this course name is dependent on course ID. Even course duration is also dependent on the same course ID. Which means, can I tell this is the determinant? Yes. And if you observe here, grade is dependent on marks. Can I tell this as determinant? Yes, all of you? All of you are getting it right, whatever I am saying. So, if you observe, all of you, we have more than one determinant existing in the same relation. Within a single relation, there are more than one determinant existing. Yes or no? That is what is called partial dependency. Everyone understood? I will repeat again. If you observe this relation is nothing but the table. This is another way of representing how we have ER schema representation, how we write the complete table. This is also another way of representing the table. This is the name of the table, and whatever we have here within the parenthesis, all they happen to be the columns of this table. So if you properly observe, you know what is determinant and what is functional dependency. Now you have that clarity. With that, when I tell the student name is dependent on student ID. So the student ID, I will tell it as determinant because it can determine the student name. Similarly, if you observe this course name or course duration, they are dependent on the course ID. So this course ID also I can tell it as determinant because it can determine the value of the course name or the course duration. Similarly, marks I have, and this grade is dependent on what marks student has taken. Only based on the marks the student has scored, we can tell what grade the student is getting. Yes or no? Which means grade is dependent on marks, and I can tell this marks to be determinant. So now, what is partial dependency if you ask me? Partial dependency is nothing but more than one determinant existing within the same relation or within the same table. You call it as partial dependency. Because in the second normal form, the 2NF, this is one condition. There should be no partial dependency. How to overcome that? I'll be telling you once we start with the normalization process. How to overcome, I'll be telling. But first, you should understand what is partial dependency. Is this clear to everyone? So this is what you mean by partial dependency. Kindly keep this in mind. Everyone, is it clear? Online students, I hope all of you understood the partial dependency. Yes. Great. Next, let me tell you about transitive dependency now. So what is transitive dependency, ma'am? Very simple, dear students. Transitive dependency is such a dependency. What happens is we will be having chain of dependencies. What we'll be having is chain of dependency. Ma'am, how do you tell that? How do I tell that? Is properly observe here. If you see here, dear students, this grade is dependent on marks. Correct? Grade is dependent on marks. Don't you think this marks is again further dependent? Oh, sorry. It is again further dependent on the student ID. All of you are getting it? Grade is dependent on marks, but marks is again further dependent on student ID. So what grade I should give to the student? Based on what marks the student has scored. Again, what marks or what is the marks that student have scored? For that, I should know which is that student. Are you all understanding here? Yes. So if you observe, we have chain of dependency. This one attribute is dependent on another attribute. Again, that attribute is dependent on another attribute. It is something like this, dear students. Say suppose I have one attribute here, A. Okay, I have one attribute A, and this A is able to determine the value of B. Again, this B attribute is able to determine the value of another attribute C. Don't you think I can tell A can determine the value of C? Understood? Technically, this is how they will tell transitive dependency. But in generally, if we have to tell it, the chain of dependencies, you call it as what? Transitive dependency. Everyone got this? Yes? So why we have to know transitive dependency? Again, I'll tell you, because in one of the normal form, that is in the third normal form, we have a condition which says there should be no there should be no transitive dependency. That is why you should be knowing what is transitive dependency. Is this clear to everyone? Yes. So transitive dependency happens to be chain of dependencies. And keep one thing in mind, dear students. Transitive dependency will not exist if in case we have only one column or two columns in a table. Minimum, we need how many columns? 3 columns in a table. Or 3 attributes in a relation. Keep that in mind. If in case you're checking somewhere, if they ask, identify any of the transitive dependency exists, you can, there only you can check. If in case there is a table or there is a relation with only 2 attributes or 2 columns, don't check for it, because how will you tell there is a transitive dependency there? So minimum of at least 3 columns you want in order to tell there is a transitive dependency. Keep this in mind. Is this clear to everyone? So all of you got the clarity on what is partial dependency and what is transitive dependency? Yes? So kindly just note this. Online students, I hope all of you understood the transitive dependency. Okay. Kindly take down partial dependency. Partial dependency. Do you want me to give any sentence for it? Okay, take down. Partial dependency exists. Partial dependency exists when partial dependency exists when there is more than one determinant, when there is more than one determinant existing, when there is more than one determinant existing in a in a relation or in a same relation. In a same relation. I will repeat. What did I tell? Partial dependency exists when there is more than one determinant existing with in a same relation. Copy the example. Which example you will copy is? Don't copy transitive dependency. Copy only the partial dependency. You can tell. Just tell student name to student ID, then course duration, and please observe here. All of you, before you write, is a transitive dependency? Any of you tell this is transitive dependency? This course name, course duration dependent on course ID. Think and tell me. I hope all of you now understood what is partial dependency, what is transitive dependency, correct? With that, you tell me, this course name, course duration is dependent on course ID, I have told, right? Is it transitive dependency? That is what I'm asking. Anybody says it is yes? Any of you think that it is yes? If in case you think it is transitive dependency, no, dear students, it is not. Why it is not, I will tell you. Here, is it chain of dependency? Is it like course duration dependent on course name dependent on course ID? Then it would have become transitive dependency. But it is not like that. Course name is also dependent on course ID. Again, course duration is also dependent on course ID, which means both the attributes are dependent on the same other determinant. So this is not transitive dependency. Keep that in mind. Did everyone get this? Yes. So this is not transitive dependency. Here, if you observe, grade is dependent on marks. Again, marks is further dependent on student ID. That is what, if you observe, we have chain of dependency. When you have that chain of dependency, only then you call it as what? You call it as transitive dependency. And this is not transitive dependency. Is this clear to everyone? So keep that in mind. Copy the example for partial dependency and I will tell you for transitive dependency also. So to understand the process of normalization, understanding all these terminologies are important because we use all of these terminologies. That is why we are discussing all of these. Online students, I hope all of you got the clarity till whatever we discussed till now. So kindly revise, all of you concentrate on what you're doing because once we finish with SQL, your whatever the MCP1, MCP2 which you have chosen, you would be starting with that. So after your SQL, your Python, those who have chosen MCP1, you will be starting with Python. Those who have chosen MCP2, you will be starting with Selenium classes. So you're moving into all of the technologies, you're understanding into all of the technologies. Moving into that, which means you should be now filled with whatever you have learned. Are you all getting it? You have to be filled with whatever you have learned. So keep that in mind. Try to be more focused. I'm not saying you're not focused now. Try to be more focused. Understand what I'm saying. Are you all getting it? Okay. So maybe if you take up, when we take it for Karnataka state, maybe your other juniors would be coming up in 5 months. They'll come out in 5 months. If you take up with respect to the universities of Andhra Pradesh and all, they come up in another 4 months. They come out in another 4 months. So think about the competition. and everything. So that is why I tell more focused on what you're doing. That's it. Transitive dependency, take down that. Transitive dependency exists. Transitive dependency exists when there is chain of dependencies. When there is chain of dependencies. When there is chain of dependencies. If you want, you can also tell one more point there. It is nothing but one attribute is dependent on another attribute and it is further dependent on another attribute. One attribute is dependent on another attribute and it is further dependent. One attribute is dependent on another attribute and it is further dependent on another attribute. And it is further dependent on another attribute. Completed? Example, just copy this. Write the same relation. Just tell grade dependent on marks. Marks is dependent on student ID. That you give. Or you can give any example of your own also. Maybe you can consider bank. Oh, okay. So you can tell it this way. Maybe if you consider the Amazon Prime membership, Prime customers. See, I'll tell you how the transitive dependency comes. Say, suppose you have the attributes like this. Amazon member ID, the name of the customer, customer ID, customer name, which is the package that they are choosing and what is the amount. Now, what amount the customer should pay in order to get the Prime membership is dependent on what package they are choosing. Are you getting it? So which means if I am telling this one particular customer has paid this as the amount. So amount is dependent on package that they are choosing. Package is further dependent on which customer has taken that package. So can you observe there is chain of dependency there? Are you all getting it? Like that, you can give your own examples. But this is one example and just copy that as well. A determines B, B determines C, which means A can determine C. Copy that as well. So you will get the clarity. So clear till here, whatever I have told till now? Everyone? Yes or no? All the terminologies? Is it yes? So these are the terminologies which you should be knowing and what each of these are doing. Okay, when I say partial dependency, what it is. When I say transitive dependency, what it is. What is determinant? What is functional dependency? All of these things you should be knowing because we need these things for the normalization process. Okay, so the normalization process is what we have to be starting next. What is it? How do we do it? By considering a set of data. I'll be showing you the normalization process. Okay, so that part we'll take up in the next class. Okay, so thank you. Let's all meet in the next class. Mark your attendance and then leave. So mark your attendance. Online students, mark your attendance. Finished marking? Online students, finished marking?